Let's take a look at molecular compounds. So to do so, we will need to be able to define covalent bond. This is a bond where electrons are shared between two atoms. A molecule, this is going to be a group of atoms that are joined together by covalent bonds. A diatomic molecule, this is a molecule that is made of only two atoms. Molecular compound. A molecular compound is a compound that is going to be composed of molecules. And molecular formula. This is how we write down what elements are present and in which numbers they are present in a molecule. This topic fulfills HSPS 3-2, communicating scientific and technical information about why the molecular level structure is important to the functioning of designed materials, and HSPS 1-7, using mathematical representations to support the claim that atoms, and therefore mass, are conserved during a chemical compound. I expect you to be able to use molecular formulas to identify the elements in a compound. That's actually pretty easy. Let's look back at the octet rule. Each of these two atoms, atom 1 and atom 2, both want to have 8 valence electrons. However, they each have 7. So how are they going to each get 8? Well, 7 plus 7 is 14, so clearly not that way. That would mean 16. But what if they shared? If they share them, and if these two atoms get close enough together that the electrons are actually in both orbits, then technically they both have 8, and this is a covalent bond. This covalent bond allows them to have 8 electrons in their valence shell by sharing one with another. And this is a good time to review electronegativity, going back to chapter 6.3. Now, a molecule is going to be a neutrally charged group of atoms joined here by covalent bonds. An example here is the caffeine molecule, where we have carbon, nitrogen, oxygen, and hydrogen all together in a molecule. So this molecule is made of multiple elements, and you can see single and double bonds in here. Those are all covalent bonds. A common example is water. Water is a small molecule with 1 oxygen and 2 hydrogens. A bigger example would be deoxyribonucleic acid is a molecule. A single strand of DNA can be very, very long indeed, but it is still a single molecule because it is joined by covalent bonds. Now, some molecules are the same element twice. For example, hydrogen, if it shares its 1 electron with one other hydrogen, both of them will have 2 electrons together, and that allows them to fill their s orbital. Remember, hydrogen is at the top of the periodic table and thus only needs to fill the s orbital. It doesn't need a full octet. Nitrogen, fluorine, oxygen, iodine, chlorine, and bromine will all share electrons in the same way. And these are diatomic molecules, molecules that have 2 atoms, often of the same element. So have no fear of ice cold beer is one way of remembering which elements exist naturally as diatomic molecules. There are other diatomic molecules like nitrous oxide and hydrogen chloride, but these are just some examples. Now, how do we turn this into a formula so that other people can read it and we don't have to draw out the whole molecule every time? Well, here we are with ethane. Ethane, as you see, has 2 carbons and has 6 hydrogens. So you count these atoms, and then you're going to use a subscript to indicate the number of atoms. So use a chemical symbol for carbon, which is C, and there are 2 of them. And use a chemical symbol for hydrogen, which is an H, and there are 6 of those. For C2H6, that's ethane. Now we're going to compare covalent and ionic bonds here. In ionic bonds, you have that crystalline lattice. Now, of course, anyone would look at this little ionic crystal and be like, but hold on, aren't sodium ions really small and chloride ions really big? Well, yes, they are. Now, that's just kind of a representative way of showing this crystal lattice. And we would say that sodium chloride is just, well, that, sodium chloride, 1 sodium per each chlorine. And that is a representative unit of an ionic compound. But a representative unit of a molecule isn't so simple. You see, here we have ethanol, which has hydrogens, 2 carbons, and 1 oxygen. So in this case, we wouldn't take a ratio. We would actually take the whole molecule. So it would be C2OH6. And that is how we would write out the molecule. So for ionic compounds, use representative units, which is the ratio. And for molecules, use, well, the molecular formula.